Morning, grade 7. I hope you had a good long weekend. We are on our 8th week of distance learning, and that means including this week, there are only 4 weeks left. So actually there's only 18 more days of online learning. And then I'll be excited to see all of you at the drive-through the week of, I think it's the week of June 15th. So looking forward to seeing you there. So push on, keep strong. There's 4 weeks left. Keep asking me questions if you need help with your math. So for today's review, we're doing a review lesson because I got the sense that we need a bit more practice with these 4 ideas: the fundamental counting principle, the factorials, and then permutations and combinations. So when you're working with questions regarding probability, you need to ask yourself 2 questions at the beginning of each question that you're trying to answer. So the first thing that you need to think about anytime you read a word problem is you need to ask yourself, is this going to be a permutation or a combination? That's the first thing you need to decide. Which one are we talking about? So you can think of an or in between these boxes. Permutation or combination. Remember, permutation, think P for permutation. The position matters. Whereas combination, that was our one where we couldn't care less about the position. So ask yourself, does the position matter or does it not matter with the position? Then you have to decide between the fundamental counting principle, which I've just summarized as counting, or using a factorial. Now, the way I think about how to use a factorial is I think, am I using up one of the choices? So again, I always think back to, let's say you're picking out prizes. I have 4 prizes on my desk. The first kid that comes up obviously has the most choices. Next kid only has 3 choices, 2, and the last person to come to the desk gets 1. You can even think about that with pizza day when they have the treats. If there's different options like bags of chips, if you're the last one to go up to my desk, you're going to get whatever is less and you don't really have a choice. So factorials when we're using up some of the choices. Whereas the counting principle is when we're multiplying all the different choices that are there and the choices don't change. So let's try and apply these questions to the next few examples that I have going on. So Ontario created new license plates this spring. They actually did do that. I don't know if you saw them. They were blue. They've now been recalled and we're going back to the original. But let's pretend that everyone we know or everyone in Ontario must get a new plate. And each plate will have 3 letters and then 3 numbers. So anytime I'm given this type of information, 3 letters and then 3 numbers, I think to myself, well, how can I picture that? Well, I'm going to picture 1, 2, 3 letters and then 1, 2, 3 numbers. Now, the first thing I'm going to think about is that question from before. Is this a permutation or a combination? Do we care about the order? Well, the answer is with license plates, of course we care about the order. If you read somebody's license plate and their license plate said 1, 2, 3, A, B, C, and somebody else's license plate said 3, 2, 1, C, B, A, I think you would agree with me that these are different license plates. The order does matter. So let's say somebody saw a vehicle speeding away from maybe a bank robbery and they wrote down this license plate, 1, 2, 3, ABC, and then this was your license plate or your parents'. The cops would not come and find you because your license plate is different because the order matters. So because order matters, we have a permutation. So that's the first thing. We do have a permutation. Now we need to decide between the counting principle, the fundamental counting principle, or the factorial. Now, if I look back at my question, it says there's 3 letters and then 3 numbers. It doesn't say anything about letters and numbers not being able to repeat themselves. So what that tells me is, for my first choice, for this first blank right here, it has to be a letter. There's 26 letters in the alphabet, so I have 26 options. But because letters are allowed to repeat, so let's say I put A as my first letter, that doesn't mean A cannot be the second letter. So I still have 26 choices for this blank. And then I still have 26 choices for this blank. Okay, because it could be A. Then I have my 3 numbers. And whenever you think about numbers, think of them as individual digits. So for individual digits, I actually have 0 through 9. So I have 10 choices, and then 10 choices, and then 10 choices. So then what I can do is I'm using the fundamental counting principle, and I can take out my calculator and I can calculate that this would give me 17,576,000 different combinations. So you can see why license plates have to be about 3 letters and 3 numbers long. In fact, in Ontario, they're actually 4 letters and then and 3 numbers typically long, because it gives you that many more options. Okay, so again, this was a permutation. The order mattered, and then we used the counting principle because we weren't using up any of our choices. All right, let's try another one. My cousin Marika owns a floral design studio. So let's say that she has 8 different kinds of flowers in her cooler, and she wants to make a bouquet with 5 kinds of flowers. How many different arrangements can she make? So I always think, okay, I'm allowed to have 5 kinds of flowers. I'm going to draw myself 5 blanks for a minute. Now I'm going to think, is this a permutation or a combination? If I think about her putting flowers in a vase, it doesn't really matter what order I put them in the vase. I still end up with the same bouquet. I could throw in a daisy, a tulip, a rose, a gerbera, and some stock. It won't change if I change the order that I put it in, because you're still going to get a bouquet with those 5 flowers. So it is not a permutation. It's going to be a combination. Now, I need to think factorial or the fundamental counting principle. Well, if I think about the first flower that I put in my arrangement, the first one I put in, I have 8 choices from the cooler to choose from. But then I've used that up. So let's say I take my tulip out of the cooler, I've used it up. So now I only have 7 choices for my next flower that I put in my bouquet. So this should look like the factorial style question to you, okay? So I have 8 times 7 times 6 times 5 times 4 to fill in those 5 blanks. But I need to remember that this would give me all the different permutations. If I just left it like this, it would leave me with just the permutations. But I want to get rid of any of the doubles. Like if I had a tulip, a daisy, a rose, a gerbera, and let's say a lily, that would be the same as me having a tulip, a rose, a daisy, a gerbera, and a lily. Just because I switched the order, it hasn't changed what's in my bouquet. So we want to get rid of all those doubles because this is a combination, not a permutation. So the way I do that is using the mathematical expression. So the top is if I had all permutations, and now I'm going to divide by how many different ways I can arrange my 5 flowers. So it said I had 5 flowers. That tells me my bottom number is going to really be 5 factorial, because this 5 factorial, which is really 5 times 4 times 3 times 2 times 1, that's really all my duplicates, where I'm basically using this to get rid of my duplicates because the order doesn't matter. So my combinations are actually less than my permutations because the order does not matter. So then what you can do is you can calculate that. Again, feel free to use a calculator for this unit. So I do 8 times 7 times 6 times 5 times 4 is the top, which gives me 6,720 permutations. But remember, I want combinations. And I'm going to divide that by the 5 factorial. Second. So I'm going to divide that by 120. So I get 6,720 divided by 120. And I get that there are actually only 56 different combinations my cousin can make. So you should notice that when we go from permutations down to combinations, there's always going to be less combinations because the order doesn't matter. So it's basically like saying if I had a tulip, a rose, and a lily, that's the same as a rose, a lily, and a tulip with a combination. They're the same. We don't want doubles. But if it was a permutation, then they would be counted as separate ones because order matters. All right, let's try another one. All right, let's say Mrs. Rakin is making a new book display at the library. She has 10 books to choose from, but only has room to show 3 books in a line. How many different arrangements can she make? Now, because we're talking about a line, we are going to count it as the order mattering, right? So here's her shelf, and she has room for 3 books, okay? So the order does matter, so this is a permutation. And now I need to decide factorial or fundamental counting principle. So let's say she goes to pick her first book. She has 10 choices to pick from. But because, let's say she picked a Hardy Boys book, now her next choice, there's only 9 to choose from, and then her next one, there's only 8 to choose from. So this is how we would figure out we're using factorials. We're just not using the whole thing, okay? We're not doing 10 factorial because we actually are only going to be using the first 3 options. So we get 9 times 10 is 90 times 8, and we would get that there are actually 720 different arrangements she could make if the order matters, okay? Now, let's say, pretend that she was going to use all the books in her display, then we would do just 10 factorial, like this, if she was going to use all the books, which gives you 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. But we did the first chunk because we're only using the first 3 books. All right, let's do one more example. All right, for my niece's birthday party, let's pretend she wants to decorate cookies. Her mom set out 6 different kinds of sprinkles, but she may only choose 3 kinds to put on a cookie. How many different arrangements can she make? So again, I always think, well, what do I start with? She can make 3. So I'm going to do 1, 2, 3. Now I think to myself, permutation or combination? Does the position matter or not? Well, in this case, it's a combination. It doesn't matter which order she puts the sprinkles on. They're all going to end up on the cookie. So now I'm going to think, okay, there's 6 different kinds of sprinkles. So for her first choice of sprinkle, she has 6 choices. Then she uses up 1. Then she has 5 choices, and then 4. We stop there because she's only allowed to put 3 cookies on it, or 3 sprinkle kinds on it. But then remember, this top line really gives me the permutations, but I want just the combinations. So I'm going to divide by a factorial. And again, in this case, the factorial is that number 3. How many different ways can I arrange 3 sprinkles? It's 3 factorial. So I get 6 times 5 times 4 divided by 3 times 2 times 1. 6 times 5 is 30 times 4 is 120 divided by 6. And I get there are 20 different types of arrangements that she can make with sprinkles. Okay, so in your lesson today, grade 7, you have 7 questions, and pretty much all of them ask you, is this a permutation or a combination? Because that makes you really think about which one to use. So work through it very carefully. If you need help, you can start by looking at the page to the left of your questions because it outlines a few more examples there for you. Feel free to give me a call or chat with me if you have